right, here is the first part of the practice test for Chapter 7. And it says to find the exact value of each. And when we are finding the exact value, we are looking at our unit circle. So when we have an inverse up above the trig function, so inverse sine, this means what angle has a sine of -1. Now, if we look at our unit circle, we have cosine and then sine. So we want the angle that has a sine of -1, and that would be here, which is 3 pi over 2. But if we remember our domain for inverse sine is between pi over 2 or -pi over 2 and our angle and pi over 2. So this angle here at 3 pi over 2, I need to write it as a negative angle because it's going to be between pi over 2 and -pi over 2. All right, so this angle right here, instead of 3 pi over 2, to fit in our domain, has to be -pi over 2. Number 2 says we want a tangent of 0. So remember, tangent is sine over cosine. And tangent also has that same domain as sine. So what we're looking for to get a 0, sine has to be 0. Okay, we don't want cosine to be 0 because that would be an undefined value. So we're looking for sine of 0. And again, tangent has to be between -pi over 2 and pi over 2. So sine is 0. That would be this angle right here. Now, it could be 0 or 2 pi, but only 0 is between -pi over 2 and pi over 2. All right, so this value is 0. Here we want to know what angle has a cosine of -√3 over 2. Now for cosine, for inverse cosine, our domain is between 0 and pi. The angle has to be between 0 and pi. So it has to be in quadrants 1 and 2. So for this one, I'm looking for -√3 over 2. Cosine is the first coordinate, and I want the cosine to be negative. That's in quadrant 2. So our answer here is 5 pi over 6. -√3 over 2, yep, 5 pi over 6, and that fits in our domain. Numbers 4, 5, and 6 ask us to use a calculator to find the values. They do want us to do this in degrees. So this one would be 5.74 degrees, 78.69 degrees, round to the nearest 2 decimal places, 82.82 degrees. So you have to make sure your mode is in degree mode before you can find those values. Number 7, find the exact value of each one of these. So here we're working in the parentheses and then we're working to the left. So we want to find cosine of 7 pi over 6. Now these can cancel as long as this angle is in the domain. All right, so as long as this angle is in the domain. So first I want to do is find cosine of 7 pi over 6. So 7 pi over 6 is right here. And the cosine is negative square root of 3 over 2. Okay, so this angle was not in the domain up here. So we just can't cancel the cosine and inverse cosine. So first, find the cosine, 7 pi over 6. And we said that was negative square root of 3 over 2. And now we're finding the inverse cosine of negative square root of 3 over 2. So this is where I have to look in either quadrants 1 or 2. Negative square root of 3 over 2 as a cosine value is 5 pi over 6. All right, so this is the angle that is in the domain. So this is 5 pi over 6. All right, next one. We want to find the sine of negative 3 pi over 7. Now, if I think about where this might be in the unit circle, I don't have an exact value for that. But because this angle, negative 3 pi over 7, would be somewhere in here. 3 pi over 6 would be pi over 2. So 3 pi over 7 is a little bit less than that. And since that angle, 3 pi over 7, is in quadrant 4, where sine and tangent have to be in either quadrant 1 or quadrant 4, we can, in this case, cancel these out, and I have negative 3 pi over 7 as my answer. Number 9, I have the inverse sine of 1/4. Okay, and then I want to find the sine of that angle. Now remember, we can just cancel these out if this angle, or if 1/4 has an angle that's in our domain. So this is saying what angle has a sine of 1/4. Okay, we know pi over 4, but not 1/4. So 1/4 is going to be somewhere between 0 and pi over 2. And that's in our domain. So the sine of the inverse sine, these are going to cancel, and I'm going to have 1/4. Number 10, I'm first looking at cosine, or what angle has a cosine of 1.2. Now, 1.2 is not in our domain. All of the angles for cosine are between -1 and 1. So there is not an angle that will give me a cosine of 1.2. So in that case, this is not possible because it's not in our domain. Okay. Any value for cosine, the highest value for cosine is 1. I'm not going to get a 1.2. Now, tangent can have any number. So we can have an inverse tangent. We can have an angle that gives us a tangent of 2. And then if I do the tangent of that, these are going to cancel. And I have a value of 2. So we can only cancel if we have values that are in our domain. Number 12 says to find the inverse. So in this case, I want to switch x and y. So y becomes x, and then I have -2 cosine of 3y. And now I want to solve for y. So I have to undo all of the things that are happening to y. So before I can undo the cosine or do the inverse cosine, I have to divide both sides by -2. So I have x over -2 equals cosine of 3y. And now I can do inverse cosine on both sides. Okay, so that looks like inverse cosine of x divided by -2, or -x over 2, equals, now these cosines are going to cancel, the inverse and the regular cosine, and that equals 3y. And now I have to divide both sides by 3. So my answer would be y equals inverse cosine of x divided by -2, and all of this is divided by 3. Or if you want to say divided by 3 is the same thing as multiplying this top value by 1/3 and have 1/3 inverse cosine of x over -2, that's fine as well. Number 13, I will replace x and y's with the other value. Okay, so I'm working backwards in terms of order of operations. So if I plug something in here, I do the sign, I multiply by 4, then I add 2. When I'm solving for y, I have to undo all these operations. So the first thing I'll do is subtract 2. So I have x minus 2 is 4 times sine of y minus 1. Then I want to, whoops, I put this over here. Then I want to divide by 4. So I have x minus 2 over 4 equals sine of y minus 1. Now I'm going to do the inverse sine. Okay, I want to undo the sine, so I'll do inverse sine. And it's inverse sine of all of this. Now here, these will cancel, and I'm left with y minus 1 for this side. I just switched sides, I don't know why, equals inverse sine of x minus 2 over 4. And then the last thing I'll do is add 1 to both sides, and I'll get y equals sine inverse of x minus 2 over 4, and then all of that I'm going to add 1 at the end. Okay. Number 14 says to find the exact value of each. And I think some of these are easiest to do on a unit circle, or label the triangle on the unit circle. So in this case, negative square root of 3 over 2. And I want to know what cosine has a negative square root of 3 over 2. Cosine has to be in the first or second quadrant, And because the cosine is negative, I know it's going to be in quadrant 2. I also know that cosine is adjacent over hypotenuse. So negative square root of 3 is the adjacent side. The hypotenuse is 2. The hypotenuse is always positive. And to find this side, I need to use the Pythagorean theorem. So I have a squared plus negative square root of 3 squared equals 2 squared. So a squared plus 3 equals 4, so a is 1. 1, 2, square root of 3. Now for this angle, I want to know the tangent. And I had to find this side because tangent is opposite over adjacent. So the side opposite is 1, and the side adjacent is negative square root of 3. And I do need to get the square root out of the denominator. So I'll multiply by the square root of 3 on top and bottom. And this will give me the square root of 3 over 3, and this is negative. Okay, so the next one, we have tangent of an angle is 1. All right, so if I'm thinking in terms of tangent being 1, remember the only way we can get 1 for tangent if sine and cosine are the same, because I'm dividing sine and cosine. So this is going to be an angle in quadrant 1, and it's going to be pi over 4. Now, if I have the angle that has a tangent is pi over 4, now I want to find the cosecant of that angle. Now, the cosecant is the same, or it's the reciprocal of sine. Okay. So how about if we do a do this a little bit different. I have 1 over sine of pi over 4. So pi over 4 on our unit circle is square root of 2 over 2. So the sine of pi over 4 is square root of 2 over 2. So cosecant is going to be 2 over the square root of 2. So now I'll multiply the top and bottom by the square root of 2. And this gives me 2 square root of 2 over 2. Those cancel, square root of 2. All right, now on number 16. Here we have the tangent of an angle is negative square root of 3. Now, I like to sometimes use the unit circle. I know negative square root of 3 is in the, oh, maybe that's not what I'm thinking. Sorry. If tangent is going to be negative square root of 3, these are easier if the inverse sine is on the outside. Okay. So if I have negative square root of 3, I am looking at the angle that has a square root of 3 in it. Okay, now remember, I'm dividing to get tangent. I'm dividing sine divided by cosine. So here, take this away here, I have negative square root of 3, and I want that to equal sine divided by cosine. So I want the square root of 3 to be in the top. And tangent is negative in quadrants 2 and 4. So let's work in quadrant 2 here. So I want sine to have the square root of 3 on top. So if I did square root of 3 over 2, whoa, you can't see that, sorry, divided by negative 1/2. So this is what I'm looking at right here. This would be, if I multiplied the top and the bottom by 2, those would cancel. This would give me square root of 3 over negative 1, or negative square root of 3. So the angle that I'm looking at here, where sine was, tangent was negative square root of 3 over 2, I'm looking at this angle. This angle is 2 pi over 3. So inside the parentheses here, I have 2 pi over 3, and I want to find the sine of that. If I look at my chart, 2 pi over 3, the sine is square root of 3 over 2. This is the answer, square root of 3 over 2. Number 17, working inside the parentheses, I have 3 pi over 4, and I want to find the cosine of that. So on my unit circle, 3 pi over 4 is right here, and the cosine is negative square root of 2 over 2. So right here is negative square root of 2 over 2. Now I want to know what angle has a sine of negative square root of 2 over 2. Okay, we're looking for sine being negative square root of 2 over 2. Now remember, when we're working with inverses, we've got to work in our domain. So this means I'm going to look in quadrants 1 and 4 for a negative square root of 2 over 2 for sine. So sine here, negative square root of 2 over 2 is this one here, which is 7 pi over 4. However, if I wrote 7 pi over 4, this is not in our domain. What would be in our domain, and still this angle, is if I'm working backwards, I call this negative pi over 4. Okay, because remember, this is 2 pi is 8 pi over 4. And I subtract pi over 4 to get 7 pi over 4. So the angle that I need has to be in quadrant 4, and that would be a negative pi over 4. Number 18. Here I have cotangent, or what angle has a cotangent of square root of 3? Now remember, cotangent is cosine over sine. and I want a square root of 3 on top. So I'm looking at, and this is a positive value, so I'm going to look in quadrant 1, because if this were negative, I would look in quadrant 2. But I'm looking for a cosine. The only angles that have any square root of 3 on them are pi over 6 and pi over 3. Okay, but I need the cosine to have the square root of 3, and that would be pi over 6, because the first coordinate is cosine. So here I have the square root of 3 over 2 divided by sine, which is 1/2. And again, this is one where I can multiply the top and the bottom by 2, and those cancel, or I can multiply by the reciprocal. That's another way to think of that as well. But this gives me square root of 3. And the angle that was pi over 6. This question says, what angle has a cotangent of square root of 3? All right, so with these, you have to do a little bit of calculating to make sure you got the right sine and cosine in the right order. And I just showed here that if I took those values from pi over 6 and I divided cosine divided by sine, I get square root of 3, which is what was over here. So this one is the cosecant. What angle has a cosecant of -2? Now remember that cosecant is the reciprocal of sine. So I want to know what angle has a sine, and the reciprocal of -2 is -1/2. What angle has a sine of -1/2? That's the reciprocal. That angle, -1/2 in sine, would be down here. That's 11 pi over 6. Again, the 11 pi over 6 is not in our domain. So because this is in quadrant 4, I'm going backwards. And from 2 pi, or 12 pi over 6, minus 1 pi over 6 is the angle that I'm looking at. Minus pi over 6. Okay, so we didn't do a whole lot with these. This is still working in degrees. I'm just going to put answers here in case you want to just play around with your calculator. This is 131.81 degrees, 26.57 degrees. This is not going to be on your test. And 11.54 degrees. And the last thing we have is solving equations. All right, so we're solving equations. In this one, we want to get x by itself. Okay, we want to find out what x is. So just like any other equation, we have to undo the things that are happening to x. So here, I'm going to divide both sides by 3. So I want to know what angle has a sine of pi over 3. So to find that out, I'm going to sine both sides. So the sine and the inverse sine cancel. So now I just need to find what sine of pi over 3 is. And if I look at my unit circle, pi over 3 is right here. The sine is square root of 3 over 2. On 24, first thing I'll do is divide by 2. So inverse cosine of 3x equals negative pi over 2. Now, before I can divide by 3, I got to get rid of this cosine. So I'm going to cosine on both sides. And cosine will cancel with the inverse. And I have 3x equals cosine of negative pi over 2. Well, I can find that value. Negative pi over 2 is right here. And cosine is the first coordinate, so it's 0. So this is 0. This becomes 3x equals 0. Divide by 3, and x is 0. And the last one on number 25, first thing I'll do is divide by 4. So I have inverse tangent of 2x equals pi over 4. Now to undo the inverse tangent, I'm going to do tangent on both sides. And tangent and its inverse will cancel. So I have 2x equals tangent of pi over 4. And pi over 4 has a sine and cosine that are the same. So the tangent is sine divided by cosine. So the same number, tangent of pi over 4 is 1. So 2x equals 1, and x equals 1/2. Okay, so that is the end of the first 2 pages. There will be a separate video for the next 2 pages.